7.2, Pythagorean, Reciprocal, and Quotient Properties. Not too much new here, and definitely not anything very difficult. Hopefully a lot of this you've already recognized through 7.1 and the exploration that we did for 7.2. Alright, so your essential question, how do you algebraically derive Pythagorean and quotient properties of trig functions? And a lot of this stuff is in your textbook, so you might want to even reference your textbook. Okay, so I'm going to draw the first quadrant of the coordinate plane, and in there I'm going to draw myself a right triangle, a right triangle. I'll have this reference angle be x, and in relation to this is going to be in relation to this angle here. We have our hypotenuse, we have our opposite leg, we have our adjacent leg. Alright, so the reciprocal properties, which you already know, so we won't spend too much time on them. Basically, the cosine of x is your adjacent over your hypotenuse, and then secant of x is the reciprocal of that, so it's the hypotenuse over your adjacent, which is really just 1 over cosine x. Your sine of x is going to be opposite over hypotenuse, and so then your cosecant of x is the reciprocal of that, so it's going to be hypotenuse over opposite. And then tan of x is opposite over adjacent, and so cotan is the reciprocal of that, so you're going to have adjacent over opposite. Alright, so we can do a whole bunch of stuff with quotient properties. So those were your reciprocal properties. You're going to have to get good at playing games with trigonometric identities. So, quotient property. Basically, if I take sine of x and I put that over cosine of x, well, what I get with that is I get the opposite leg over the hypotenuse, right? That's the sine of x, divided by the adjacent leg over the hypotenuse. Okay, so what does this actually equal? Well, this is opposite leg over hypotenuse times, multiplied by the reciprocal, hypotenuse over adjacent leg. Those reduce. And what I'm really left with then is opposite leg over adjacent leg. Well, what is opposite leg over adjacent leg? That's tangent, right? So we just proved that tan x is the same thing as sine over cosine x. Okay, so therefore, we can say that tan x is equal to sine x over cosine x, which then we also will know the reciprocal of that, right? That cotangent of x will then be cosine x over sine of x. Pretty cool, right? Alright, now that we know that tan of x is the same thing as sine of x over cosine of x, we can now take those reciprocal properties that we know about and come up with an equivalent form of tangent using secant and cosecant. So we know that sine of x is the same thing as 1 over cosecant x, and we know that cosine of x is the same as 1 over secant x. So if we take those two things and we divide them, again, we don't divide fractions, so we'll multiply. And so what we get is we get secant x over cosecant x. Therefore, we know that tan x is the same thing as secant x over cosecant x. And in addition to that, then we should know what cotan x is in terms of secant and cosecant. Oops. Having a little technical difficulties with my pencil. Okay. That will be cosecant x over secant x. Just as a reminder, and you got to explore this a little bit today, but if I draw the first quadrant, and in that first quadrant I draw a right triangle, and I label the reference angle theta, and I've got one side u and one side v, and then a hypotenuse of 1, then I know by Pythagorean theorem that u squared plus v squared will have to equal 1 squared. Well, think about this. U is really, if we think about the cosine of theta, you're going to get adjacent over hypotenuse. And if we think about sine of theta, you're going to have opposite over hypotenuse. So really, cosine of theta is going to be u, and sine of theta is going to be v. So if I take these values and I plug them in instead, and I have cosine squared of theta plus sine squared of theta, right? Since v is really sine, if I square that, I get v squared. That will equal 1. And there's your Pythagorean identity. And then you did something similar to this in your exploration, where we basically took that Pythagorean identity. I'll use x this time. And we divided everything, both sides, by cosine squared. And when you do that, you end up with cosine squared x over cosine squared x plus sine squared x over cosine squared x equals 1 over cosine squared x. Cosine squared x over cosine squared x is 1. Sine squared over cosine squared of x is going to give you tan squared of x. And then 1 over cosine, well, that's secant, and if we do it over squared, then it's secant squared x. So there's another Pythagorean identity. Notice I'm using the x's and the thetas interchangeably. We'll do this one more time to get one more of your Pythagorean identities. So last one we're going to do, we'll start with the original cosine squared x plus sine squared x equals 1. And this time we'll divide everything by sine squared x. So we get cosine squared x over sine squared x plus 1 equals, cosecant squared x. Or in other words, you get cotan squared x plus 1 equals cosecant squared x. These will become really important. It's important that you recognize all these. To your best of your ability, you should have this one memorized and be able to derive the rest of them. And you will need to use these kind of like in little trig puzzles where we come up with identities in our next lesson.